Welcome to Walkabout the Galaxy, the 2022 astronomy podcast, where the science is universal, the opinions are personal, and the hosts are the Fab Four. We are Strange, Up, Charm, and Top, the Astroquarks, also known as Josh Caldwell,
Hannah Sargent,
Addie Dove,
and Jim Cooney.
Coming to you from a virtual space. Be sure to check out the 8-hour documentary about our creative process, now streaming in my imagination on all major platforms. Remember to subscribe to us on YouTube, Facebook, Twitter, and Instagram. Follow the Astroquarks on TikTok, where we have one virtual planetary dance on the books and more to come. Is that not so, Top Quark Jim Cooney?
For sure, dude. For sure.
All right.
2022,
website,
the year of
the year of the Astroquark
TikTok.
TikToks. Our website at walkaboutthegalaxy.com is undergoing repairs, but you can order a Walkabout shirt and support STEM education at the same time by sending an email to wtg@ucf.edu. Our stumper today is aspirational. I know that we were all watching, I assume, on Christmas morning on the 25th to see the launch of the James Webb Space Telescope, which was successful, and its various unfurlings have been going smoothly and successfully as far as we can tell so far. This was a mission that we've all been waiting for a very long time, and it cost a fair chunk of change as far as science activities go, sort of drop in the bucket as far as some other activities that governments engage in, but as far as science goes, it was fairly expensive. So if you had full authority to spend $10 billion on the next great space science mission, what would you do? Hannah Sargent.
Oh, it's got to be human spaceflight related for me. So some kind of demonstration of water production, full-scale water production on the moon to support a moon base, fully functional moon base. And then we can do science with humans.
Okay, so you'd send something to the moon that would, like, a processing plant to convert moon dirt to water and get hydrogen, oxygen, all that good stuff.
All of it, just all that enabling technology so that we can actually finally, because it's like this hurdle that is just a nightmare to get funding for. So if I had a pocket of money that I could just dip into, we could just get past it, get that kind of industrial side out of the way, and then we can get the fun stuff
started. It out of the way. So then we could really go to town. Okay.
Yeah.
That sounds good. Addie, what about you?
I like Hannah's idea because I think it enables a lot of cool science that would happen on the moon. I think another, this is tricky, but another sort of grand tour type mission, where there was some big mission, that planetary solar system mission that went and explored a bunch of different planets in the solar system and actually got out to the outer solar system and stuff like that. Like the Voyagers were once in several lifetimes opportunity, right? In terms of like how the alignment of the planets facilitated those missions. But like if we could do something like that again, and we have better fuel and better rockets and stuff like that now, and I don't know, something like that would be really cool.
So you want to get
or a sample return mission from lots of different places.
A sample return from lots of different places.
Yeah.
Yeah,
that's
you might
be
busting even your $10 billion budget for that. Yeah.
Maybe like two smaller spacecraft, like one on the moon and one on, I don't know, an asteroid or a couple asteroids or something for sample return. That would be a very large budget, though. You can pick one.
Okay. So not the Mars sample return.
I think that's already in the budget. It's fine.
All right. You want to go beyond that. Yeah. All right. Yeah. Jim, what about you?
I was really bummed that that NASA some years ago pulled out of the LISA mission. LISA was the gravitational observatory in space. Where the arms of the gravitational observatory are a few million kilometers rather than just a few kilometers like LIGO here on Earth. And so I'd love to see us get back involved in that. That's still moving forward. I mean, it's not launched yet or anything, but the European Space Agency is working on LISA. But we pulled out of that. So I'm putting our money back into gravitational waves so we can see supermassive black holes collide and fun things like that.
So is that, is that mission, do you think, going to happen even without NASA involvement? Just it'll take longer before it
Yes.
happens, and
Yeah.
that's
Yeah.
what you want to see it happen sooner
Yeah. I want to
rather
see it
than
happen.
later?
Yeah. Yeah. I mean, obviously, the more money they have for that thing, the better off it's going to be. They are still moving forward on it, and in fact, they had a kind of a proof of concept thing already. They launched, and I forget the name of it now. It was Lisa something, where they launched they had arms of a few centimeters. They're just making sure that like there wasn't a lot of noise. They could do a space interferometer, and it worked out really, really well, way better than they expected. So this is going to happen, but not till the 2030s most likely. And yeah, with
You'll still be
huge...
around in the 2030s, Jim.
Will I? Will I though? Have you seen my diet?
I hope so.
I actually have seen your diet, and maybe I should reconsider.
Yeah. I had bugles for lunch today. That's not going to do it.
You definitely have a preference for what I like to call the beige food group.
Yeah. That's true.
The lightly fried colored food group. Yeah. Well, not that anybody's asking, but I think I would put my money on a mission to land on the South Pole of
Enceladus,
the moon of Saturn. You're right, Addie, Enceladus. To land at the South Pole of Enceladus with something that can check out what is going on with those geysers coming out of these giant crevasses at the South Pole, and really study that material well, and maybe do some subsurface sounding. I think for 10 billion, you could pull that off. I think.
Could you imagine if you land there and then you just happen to be there just at the wrong time and suddenly get erupted back out into space on top of a geyser?
That would be bad. Yeah, there's not a huge amount of force coming from those molecules, I don't think. We will talk a little bit more about Enceladus and the year ahead in space science today, but first, this episode of Walkabout the Galaxy is brought to you by Earth's L2. Just 1% further from the sun than the Earth, this gravitational saddle point is a great place for a space telescope to saddle up for an exploration of the cosmos. While unstable, this gravitational equilibrium takes just a wee bit of fuel for your favorite spacecraft to maintain a Lissajous orbit, so its solar panels can bask in the full sun 24/7, and its giant mirror can scan the cosmos 365.25:1. While L5 may be the place for your future space-based colony, thank L2 for providing your eye on the sky for a safe place to fly. L2, life's good. I'm done.
Oh, life's... Isn't that just like a brand?
Which it better known as
LG.
Yeah.
Oh.
Not L2.
Okay.
No, not L2.
Nice.
Yeah. I was like 24/7. Then I was like, what's the year version of that? Well, it's 24 hours, 7 days a week. I don't know, 365.25 days a year per year.
That's correct.
365.251.
Good job.
Here's a bonus advanced trivia. James Webb Space Telescope, of course, is en route to Earth's L2 point, one of these 5 Lagrange points. The Lagrange points have previously collectively sponsored the show, but this is the first one sponsored by this individual Lagrange point. And it's an equilibrium, but it's an unstable equilibrium. So any slight perturbation, you fall away from it. So it has to use its thrusters to stay in its sort of funky, what they call a halo orbit around this empty point in space, the L2 point. So the sort of bonus advanced for you is like, how much delta V does James Webb have to use each year to sort of maintain its station keeping at L2? And I'll give you some points of reference. So the Earth's speed around the sun is 30 kilometers per second, ballpark. And so James Webb is about the same, about 30 kilometers per second. That's how fast it's orbiting the sun. So it needs a little bit of delta V from its thrusters to stay in this sweet spot each year. That's how rocket scientists sort of measure their fuel usage. How much delta V do you think James Webb needs to use each year to stay there?
1 meter per second.
Jim says 1 meter per second.
25.
Yeah, I was going to go something like, what, Hannah?
25 meters per second, but on the same scale.
25 meters per second. Uh-huh.
Okay, I was going to go something like half a meter per second.
Okay. Well, I congratulate all three of you for being in the right general ballpark. The number is 2.5 meters per second. And so
job,
well
Jim.
done, because I don't know if I would have had any, inkling about how much, but the space, that's ultimately going to be one of the limiting factors for the duration of the
So
missions.
like almost 10%?
Of what?
Of like its V.
No.
Way less.
Its V is 30 kilometers per second.
Yeah. Sorry.
30,000 meters per second. So yeah.
With its fuel tank,
%.
what's its lifespan expected to be?
So yeah, that's exactly the question. I think it has. They're expecting it to have about 100 meters per second available when it gets there, which is a little bit more than their requirement because the launch everything has been working beautifully. So the launch was right on the numbers, so they didn't have to use as much of its fuel to sort of get it on its way to L2. So based on that, it's got a pretty long lifetime ahead of it. There may be some other limiting factors. The nominal mission lifetime is 5 years, aspirational 10, but I think sounds like it could well go beyond 10 years, at least from maintaining its orbit. So, yay.
I'm not going to lie. I'm surprised that it went as smoothly as it did.
Right?
Everything has been going perfectly. So
Yeah,
hats off.
Every time I see a little story like the solar shield got out there and did everything it was supposed to do, didn't tear, didn't do anything crazy. I mean, every one of these things I think is like a nail biting thing. Is it going to work or not? But so far,
and there are so many of these steps going on, even as we record. They're now at the process of unfolding the primary mirror, which is pretty exciting. So,
I mean, even with like the Lucy mission, right? There was some issue when it unfurled its solar panels, like they didn't latch properly or something like that. And like stuff like that just happens, and then there's, I don't know, not as much you can do.
Right, so and there's like 250 opportunities for stuff like that to happen on this mission, and so far it seems like none of them has happened. Yeah, so that was really great space news to finish off 2021. And you may recall that our last episode of 2021 was our typical sort of year-ending launch tally. And when we recorded that in 2000 on December 10th, we had a pretty good number of launch attempts in 2021, but we had not set the record. And Addie, you may remember that the record year for most orbital launches was way back in 1967. Well, in 2021, that record was finally broken.
Yeah. Right at the last second.
There was a flurry of launches in December, 20 orbital launch attempts, 17 of which were successful, bringing the total for the year to 146, 135 of which were successful, edging by the long-standing record from 1967 of 139 orbital launch attempts. So, and of course, one of those that we were just discussing was JWST. So, pretty exciting. Ingenuity has its 19th flight coming up today or tomorrow. It has traveled so far a total of almost 4 kilometers over the surface of Mars. So it's
pretty impressive.
Surpassing its design. Yeah. Other space news. Did you guys want to offer up? We're closing in on our deadline for listener predictions of the number of Starship orbital launch attempts in 2022. Let's get the AstroQuark predictions on number of Starship launch attempts. Orbital, so not these little suborbital test flights, but the full 120-meter ginormous stainless steel Flash Gordon-esque stacked rocket. How many times do you think we'll see that lift off the launch pad this year?
This is launch attempts, not successful.
It can blow up. It still counts if it's off the pad.
Okay.
If it's trying to get to orbit and it lifts off, that counts.
All right. Nobody?
I have no idea.
I'm going to say 3.
248.
Oh, come on.
18.
I don't know. I don't know the right order of magnitude. I don't know what's that. I know it's not 248.
Okay. Well, we don't know. It hasn't happened. Elon Musk was talking about on the order of a dozen. So I kind of like Addie's guess of 3. So we'll see. We will see. We had some a number of listener requests for our response to the Netflix movie Don't Look Up, which I believe we've all seen.
We have.
What are your thoughts? Well, I was hesitant to watch it because I thought it would drive me nuts and or depressed. But I actually enjoyed it. It didn't. Okay. No, it didn't. I didn't find it overly depressing, and it also didn't drive me nuts. I found it all entertaining and sadly believable, but not depressingly believable.
I was deeply depressed. I did find it enjoyable. It was a fun movie. It had a lot of great actors in it, and thought it was well done, but it was very depressing.
So and this is a movie on Netflix about a comet that's discovered that's a sort of civilization-ending catastrophic event, even worse than civilization ending, sort of at the dinosaur extinction level event.
Yeah.
Impact course, and it's about society's response or lack of response to it.
As an analog to the climate crisis.
Yes. Right, that was the thing. Yeah. It was very not so subtle. Yeah, I mean, the disappointing thing, or not disappointing thing about the movie, but the depressing thing, of course, is just that it's highlighting how little people listen to scientists about things, right? So they just refuse to listen to facts and science. And obviously it's just supposed to be an allegory for what the world is doing with climate change. Even though this thing, everybody dies on a particular day or something like that. The climate thing isn't obviously such a, it doesn't happen as fast. Although geologically speaking, it's irrelevant. It's kind of the same time scales and geological time scales. But that's the depressing thing. It's like scientists have been saying for decades, look at this giant disaster coming, and nobody's doing anything about it. And
I think a lot of the point of the movie that they do make is that it's the media coverage and the way politicians and people in power deal with it, not necessarily just the people on the ground. Because at first people want to believe it, and then when they hear it from people, they believe it, and then when they're going to do something about it, everybody's happy about that, right? But it's there's politicians involved, and then there's this weird billionaire person who's super creepy involved.
Oh, yeah. The sort of a Steve Jobs kind of
it's like an Elon Musk, Steve Jobs kind of person. Yeah, that's like this.
A mashup of all the billionaire space people.
A creepy man baby.
Yeah.
Yeah. I didn't love it. I think I was just in a weird mood when I was watching it, and it just was too long, I thought. But I did appreciate, and I liked it more, I think, as I went on, except that it just kept going. But I did appreciate it for what it was doing.
So what about the science? What if we don't worry about the allegory, we just talk about the science? Was it good?
It was mostly fine.
Well, it made one same mistake on a sort of big level that Deep Impact also made, which is this idea that not every single astronomer all over the world would see this comet and know about it. It's these things are not hard to see. It's okay, somebody's the first to see it, but then everybody else goes and sees it. Telescopes are all over the place. Everybody in every country would see it. So that sort of initial denial that this thing is even out there phase is not really believable.
And I think that's why I didn't like I sort of had a negative emotions about the movie, just because that beginning hour where there's they're trying to meet with the president and there's all this denialism and it takes forever and it's all hush hush. Right. And that just didn't happen.
Right. Yeah.
And as
Like
well,
that's just not how you're not able to keep something like that a secret.
I found because
Yeah.
the team that discovered it, they're not, these planetary protection kind of people, but they become the experts just because they discovered it, and that for me wasn't then believable
Yeah.
because that's not their field, but they became kind of the character that was shown. And the only other thing that kind of wound me up, which I've seen other people talk about as well, was that this experienced scientist, career scientist, was terrified to speak in public. I'm like, it is part of being a scientist to be able to deliver talks. Not they wouldn't fall apart. I feel like
you
the
met a
panic
lot of
attack was a bit
scientists?
much.
I don't.
I found, he said something. His character. This is Leonardo DiCaprio's character said something at the very beginning about how he hasn't published in a while. So I think he's sort of, not a scientist that's going to a lot of conferences and giving a lot of talks.
Yeah.
That was kind of the impression that I got.
And also not at the like sort of publicity scale, like that kind of talks.
Yeah.
Some of our colleagues are not as comfortable talking to a crowd as you are, Hannah.
You know what bugged? The thing that bugged. Go ahead, Josh.
Well, the only other thing I was going to mention is they really sort of shortchanged and left Europe out, which I thought was odd. It's like NASA does this whole response, and they mention Russia at some point, which had in principle like teamed up with China or India or something like that. But it's like ESA has got a very robust launch capability, and they were never mentioned, and they would have been doing something too.
And I noticed something about it's something I've picked up since working in the US, because when they're in the president's office and they're from this university that isn't an Ivy League, and so they disregard them instantly. Right. That's like an attitude that I've generally found out in the US, which isn't quite as much of a thing. Okay, yeah, we have Oxbridge here, the Oxford Cambridge, but it's not like if you don't go there, then you're not good. It seems, it was just quite funny to see that represented in the film.
Yeah.
There's definitely that was
Yeah, I think a little detail that bugged me a little bit at the beginning was how they saw this thing for a few days or something like that, and then were able to, or even less than that, and were able to calculate with 99 or 100% precision that it was going to hit the Earth. Like it takes. There's a lot of uncertainty in early data like that from comet, so you don't know exactly where it is and how fast it's going, and it takes a long time to actually get an orbit calculated carefully enough to know that it's going to hit the Earth. Obviously, they're just shortening all timescales because it's a movie, but that's not how it works.
And it's particularly hard to know that for a comet because they have what we call non-gravitational forces, which is as the comet comes close to the sun, it starts evaporating, and that evaporating those molecules are like rocket thrust, and they push the comet around not entirely in predictable way. And so there's even greater uncertainty about the path of a comet, unlike an asteroid where you can really have a much smaller uncertainty. But even with the asteroids, they
early after a few days worth of data, and they were even telling you where in the Pacific Ocean it was going to hit, all that kind of stuff. 6 months out or whatever. Like that's after. And there was one thing I had a question about. I don't know. You guys could maybe answer this for me that I thought was weird. It was visually cool. Like when they were launching the missions to they launched. The U.S. took
50 rockets at once.
Yeah, they launched them all at once, and I thought that's pretty dangerous, crazy, right? Would they conceivably do that?
No.
I didn't think so.
No. There's no point in doing it, and it's make everything more dangerous and difficult. So
they forgot to
even Armageddon did that better. Come on.
Well, there's another. When is this thing Moonfall coming out? What's the story on that one?
Never, hopefully.
Yeah, I think I forget when it's supposed to come out. It's this year now.
But that one is, I think, in the sort of, we've mentioned Armageddon and Deep Impact, which came out the same year and had very different approaches to realism. Whatever you think of the two movies for entertainment value, they had fundamentally different approaches to whether or not they were pretending to operate in the real world or not. One of them was making some effort to, and the other one was sort of deliberately trying not to. And I think that we may see the same thing between Don't Look Up and Moonfall.
Is
With
Moonfall,
Moonfall,
is it supposed to be a parody of disaster movies, or is it actually just terrible
No,
concepts?
it's a Roland Emmerich film, right? So he just does all these disaster movies, and it just doesn't matter how realistic the scenario is. He's just going to make a disaster movie.
Well,
It's got
we'll have
Halle Berry in it. We've got to watch it.
Yes.
I don't know if I can watch it. It might require alcohol.
Oh, now that sounds entertaining.
We could maybe do a drink alcohol and watch it and record ourselves.
Let's have a watch party so we can at least we can be entertained by watching Addie watch the movie.
And Hannah. It's February 4th is maybe the release date. So
okay.
I mean, like, I think that whole one is that there's some premise that it's like the moon isn't just the moon, actually, right?
Right.
Oh,
which is the
we
first
know
point
that's
of
true
deviation
anyway. We just saw a hut on the moon. We know it's not. There's something going on.
Oh, don't bring up the hut. We know it's not a hut anymore. It's a bunny.
What is it?
What they said.
Come on.
They've called it the Jade Rabbit or something like that because they've. So yeah, this is this hut. This hut that they thought. Not an actual rabbit.
An actual rabbit on the moon. This podcast is better and better.
The Jade Rabbit is the whole is the Chinese thing for the moon. Oh. Right, like U2, the rover, and the landers and stuff are Jade Rabbit.
Let's back up. What's the hut update?
The hut update. So this is referring to this U2-2. It's I think it's U2-2. The rover from the Chang'e 4 mission on the far side of the moon. They saw this blocky image in the distance, and everyone said, "Oh, there's aliens on the moon. They've got buildings." And of course, our response was, "No, it's a boulder." And lo and behold, it's a boulder. So they've got this image. They've released this. I think it's today or yesterday, and it's. They've described it as this little rabbit-looking rock, and there's some little pebbles or smaller rocks in front and behind it, which they've described as like the carrot that it's eating, and behind it, what's left after you eat a carrot. And this is.
So you're saying the scientists' response to everybody saying this rock on the moon looks like a hut was, no, it's not a hut. It looks like a rabbit.
A rabbit-shaped boulder. Which is key.
Okay. Well, before we get into our two science topics, since it ties into some of the space news we're going to be talking about, let me give you the main trivia for today. As we mentioned, JWST is heading to the L2 point with the Earth-Sun system. That's one of 5 stable equilibrium points. We've previously talked about the Lucy mission, which was launched last fall, which is en route to visit asteroids orbiting in the L4 and L5 points with Jupiter in the Jupiter-Sun system. The question, there are more than 1 million known asteroids in those L4 and L5s with Jupiter. Your question is, how many known asteroids are there in stable Lagrange Lagrange point orbits with other planets in the solar system?
Not including Jupiter?
Not including Jupiter. So we'll go planet by planet and see what you think about that when we come back to that. So there are more than 1 million with Jupiter. Are there any with Mercury, Venus, Earth, Mars, etc.? So that's our trivia today. Now let's get the hell out of the solar system for a bit here, because it's been exhausting and a little bit depressing. Tell us about antimatter. Let's talk about antimatter stars.
Yeah. Antimatter stars. It wouldn't be awesome if they existed. Whole stars made of antimatter. Yeah. It's conceivable they do, but not really.
What would an antimatter star be, Jim?
What do you mean? It'd just be a whole bunch of stars made of antimatter. So here's the thing. There's an instrument aboard the International Space Station, the AMS, which stands for what? The
Alpha Magnetic Spectrometer.
Yeah, Alpha Magnetic Spectrometer, where they claim to have possibly detected a couple somewhere between 2 and 8 or something like that,
Yeah.
anti-helium nuclei. That would be very, very surprising. So an anti-helium means 2 antiprotons and 2 antineutrons to make an antimatter helium nucleus.
Just to clarify, so this is from impact of these things on an in situ detector or from remote sensing?
Impact of those things. So they've impacted the sensor, caused some. I mean, they're not seeing the nuclei directly, but they're seeing the byproducts of, in theory, possibly seeing the byproducts of the reaction of these things with the detector.
They've gotten a handful of signals, and their best, or one of their best interpretations for that signal is that it was caused by a nucleus of anti-helium.
Right.
Hitting the instrument.
That's the idea. Now, to be clear, those results have not been published, not been peer-reviewed. This is just some kind of initial stuff that's out there. And if that were true, and it's not probably, but if it were, that would be very, very intriguing because, I mean, antimatter exists. I mean, we make it in particle accelerators, and it happens, and it's going to be made occasionally in big things, supernova explosions, various things. But to make one anti-electron or an anti-proton, that's a doable-ish thing. But to make an anti-nucleus, that requires a bunch of antimatter to be together in the right place at the right time to come together. And so that is next to impossible. And so to observe multiple of those in our detector would mean that there has to be some very significant source of production of anti-helium out there. And the best guess for that would be in fusion reactions in an anti-star, right? So this is where a lot of the helium in our universe comes from, is from, making it by fusing hydrogen into helium in stars. And so if those results are right, then that's really interesting. Then there might be anti-stars out there. The trouble is, that's ludicrous. How would that happen? How would that antimatter that made up the whole antimatter star, how would that have escaped annihilation with all the other matter in the universe by now?
Right.
And that seems like an extremely, extremely unlikely scenario. And even the people at the AMS, at that instrument, know that and say, this probably isn't right, but we can't explain it otherwise yet. So here, kind of a thing.
Because while stars are generally far apart from each other and hanging out in what we call the vacuum of space, that space isn't really empty. And there's something called a stellar wind. So the star sheds material. So if you have an antimatter star, there would be antiprotons streaming away from it, just as there are protons streaming away from the sun, correct? And those antiprotons would encounter normal protons as part of the interstellar medium, right? And they would annihilate.
They would annihilate, producing gamma rays, and we look for gamma ray sources, and we just don't. You could put upper limits on how many of these there could possibly be out there based on just our observations.
You would
of gamma
expect
rays.
some sort of gamma ray glow or something from the system, even if the star itself is like not blowing up. Its solar wind would be producing some sort of gamma ray glow.
It absolutely would. And then you have to ask questions like, how did it form in the first place? I mean, stars form from these big, clouds of gas and dust. So the whole cloud of gas and dust would have to be antimatter to begin with. But big clouds of gas and dust do interact with one another in a galaxy. And then they would have annihilated before this thing ever made a star. That would have been enormous.
I found it interesting looking at the article, just how they've got these results. I don't know whether it was as a result of getting this preliminary data, but then they've gone or some groups have then gone to like theorize, okay, so how many of these stars could possibly exist? How would we detect them? What are we looking for? It just seems like a big jump to go from, as you say, something highly unlikely to let's go search for antimatter stars.
Right. So they're not gonna win any $10 billion missions to go search for these things. But you can just go back and look at X-ray data and things like that and see if you could find.
They use
a good fun project for a grad student or something like that to go do.
Yeah, they use the Fermi Large Area Telescope, like 10 years of data from that, so gamma ray data, to look for like possible signals but basically drives the upper limit pretty low on
Yeah.
possible sources.
Uh-huh. But another use for this kind of discovery would be to provide maybe a slightly more scientifically plausible idea for Roland Emmerich's next major space disaster movie.
Yes.
This
Yeah.
sounds more
Instead of
believable than
having
Moonfall.
the
I know,
moon
right?
isn't really a moon and it's got black goo inside of it attacking the Earth or whatever is going on in that movie. Maybe have an antimatter star out there.
It's the reason we have a helium shortage now, is because all this anti-helium is hitting us and destroying our helium supply.
Son of a gun.
Okay.
Son of a gun.
There you go. Now we're on to something. Well, back closer to home, before we wrap up, the place I said I would spend my $10 billion is going to the South Pole of Enceladus, which is cool because it has these 4 major fissures or crevasses called the tiger stripes that have, for the time that we observed it with Cassini, continuously spewing out water vapor. We know it's water vapor because Cassini flew through those and sampled the atoms and molecules directly, and the instrument I worked on, the ultraviolet imaging spectrograph, measured the absorption spectrum of light passing through those plumes and saw it was water vapor. Lots of studies suggested that that's coming from basically evaporation from a subsurface ocean underneath the surface of Enceladus. New results say there may be a different sort of explanation.
Yeah, so there was a presentation at the American Geophysical Union in December. So this is AGU. It's a big conference we often go to, but it was a hybrid this year. And anyway, so these results are sort of I don't know if they're published yet, but it's this study that sort of looks at the likelihood of it coming from an ocean, which is like pretty deep in the subsurface, right? And so you have to be able to get the water from deep in the subsurface all the way up through some sort of fissure that would go all the way down to the ocean, and so that it comes out on the surface. And these people argue that that's unlikely for a number of reasons, partially because like as you get deeper, the ice itself is going to become more ductile, more easily, like more flexible, basically. And so you're not as likely to have like a big crack and a fissure down there because things are going to be moving around and getting sort of more pliable, right? So it's maybe more likely that you have sort of a mushy, they call it a mushy ice region that's generated sort of around a fracture closer to the surface, which if you live in like the Northeast right now, or most places in the US, or a lot of places in the world right now where you're having snow and ice fall and then it warms up maybe a little bit, you get lots of little mushy ice regions,
I'm familiar with that mushy ice, right?
And so maybe it comes from these water sources are actually coming from those that are higher up, so it's not actually sampling the deep subsurface ocean.
I guess one of the problems with that is because a lot of I suppose a lot of research to do with Enceladus is these salts that get brought up from what they thought originally was this ocean. If it's being erupted and then it rests on the surface, it was a way for us, if we could land on the surface of Enceladus, sample that material, we thought, oh, maybe that will tell us what the conditions are like in these deep subsurface oceans. But if it isn't coming from that far deep, then we're only really sampling the conditions of this mushy pocket of material. We still don't actually know what's going on real deep down below the surface.
And there's also some missions proposed to do like flybys where they would sample the geysers, right? So you don't even have to land; you can just sample some of these geysers, and then you're sampling the deep subsurface. But if that's not the case, I mean, you're still sampling parts of the subsurface, right, and the ice itself, but maybe not the sort of most habitable zone of the water ice.
So my question to you guys then is, so it seemed like I did a quick read of that article, and I didn't. It seemed like they still suggested that the ocean is still there, but that the geysers just might not be sampling the water from the ocean, might be sampling the water from this mushy region. What is the evidence that the ocean is there if it's not just the stuff coming up from the fissures?
That, I believe, has to do with the libration of the moon.
Ooh.
And so
that moon's always getting librated.
Fancy word. I like it.
So a similar thing was done with Titan, the Saturn's largest moon, second largest moon in the solar system, which we believe has a global subsurface liquid water ocean as well, much, 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 much deeper below the surface, hundreds of kilometers compared to maybe only a few tens of kilometers for Enceladus. And that's by looking at the gravitational field of the moon and the way it responds to tidal forces from Saturn as it orbits. It's not on a perfectly circular orbit. And if you see the outer part of the moon moving a lot, that suggests that it's not rigidly coupled all the way down to the surface or vice versa. I confess I don't remember exactly which way it goes, because it's sort of like spinning an egg. If you spin a hard-boiled egg or a raw egg, it behaves very differently. You apply the same torque to it because of the coupling of the forces through the interior. And so, in some sense, the tidal forces of Saturn acting on these moons is kind of like your fingers spinning an egg, and we can observe the response of the moon to that spinning torque and then determine whether or not it's tightly coupled by being a solid, rigid body all the way through, like a hard-boiled egg, or loosely coupled, like an uncooked egg.
Gotcha.
Yes.
Gotcha. All right. So ocean is probably there, but we might not be getting at it by looking at the stuff, which is kind of fun.
So I'll maybe have to rethink how I'm going to spend my $10 billion.
I mean, you might still get interesting things. I also like that the model they used was called softball. Personally.
Okay. Well, I have lots of memories of mushy snow from my days in Colorado. Are you experiencing any mushy snow in London right now at the moment, Hannah?
So I missed the snowfall just before. There was quite a heavy snowfall just before I arrived, and there's probably going to be more when I leave, I think.
Yeah.
As is the way.
So just mushy peas for you then at the moment.
Oh, yes, mushy peas. Oh, with fish and chips.
Yeah.
Oh, don't get me started. Oh.
Grotesque. Oh my
Okay. All right. Well, I'll distract you with our technical trivia, which is how many asteroids are in Lagrange point orbits other than those at Jupiter? And we're going to skip Mercury. There are none there, at least that we know of. And of course, these are all just ones that we know of, right? So
Sure.
Let's start with Venus.
1.
Jim says 1.
I feel like
none.
0.
Jim is exactly correct.
Oh, well, plus or minus.
Yeah, within uncertainty.
And the rest of you are only 1 sigma away, really. So, there is an asteroid 2013 ND15, so a relatively recent discovery at the L4 with Venus. How about Mars?
Mars is a bunch. 10. I'm going to say 50.
There's 1 at the L4 and 4 that we know of at L5, with a couple more that are potentials at L5. So we're looking at 5 with 2 potentials, so 7 at Mars.
Wow.
Jupiter, we have more than 1 million. Saturn, second biggest planet in the solar system. What do you think?
3,000.
100.
100.
None.
Does Jupiter just take them all away?
So I'm not entirely sure what the explanation is for that. It's a massive planet, obviously. Its orbit is fairly eccentric compared to Jupiter's. I don't know if that would have anything to do with it. Mars is on an even more eccentric orbit, so I assume not. However, 2 of Saturn's own moons have their own Trojan companions in their orbits around Saturn. So that's something going on there. How about Uranus?
How about Uranus?
Hey.
I was just repeating the question.
Here.
1.
5.
Okay, Jim, you're thinking too long. You said 6. I missed it. There's actually 1 at Saturn at Uranus's L3, which means exactly on the opposite side of the sun from Uranus. So it's not a stable equilibrium, but there is a named object there, 83982 Crantor.
Ooh.
Nice.
and
Strong.
then a couple at the L4. And quickly, final guesses for Neptune.
0.
None.
2.
6
0.
at L4 and 3 at L5.
Oh,
Man, we're bad at this.
Yeah.
Well,
No
not
instinct.
really. Actually, I don't think. I don't know. The Saturn one is the puzzling one.
Yeah.
But otherwise, it's sort of interesting that there are a handful of these at the other planets, but Jupiter has this gigantic population of them. Some of it may just have to do with the sort of overall dynamical evolution history of the solar system. But yeah, and most of these that we've talked about, or many of them, have only been discovered in the last 10 years or so. Not very big. Of course, Uranus and Neptune much further away, so it's harder to see things out there. So we may discover more as the observations continue.
Are we going to have predictions for launches this year?
Go for it.
160.
All right. What is it?
Hannah says 160 orbital launches.
Okay. I like it. I'm going to say 156.
Ooh.
284.
I'm right. How many?
284.
We just broke the record.
That's not
and
the same
doubling
number
it.
that.
Yeah, that is the same number that I picked for the other one. They're all going to be launches from. Yeah.
What did you say, Addie?
156.
156. And Jim says 284. I'm going to say 120, just to be a contrarian.
All right.
Yeah. Well, it may have felt like another COVID surge. It was just another episode of Walkabout the Galaxy. Give us 5 stars and we'll give you the universe. Be sure to follow us on Facebook and Instagram to get all our updates, and check out our website at walkaboutthegalaxy.com. Subscribe to our YouTube channel where you can see most of our episodes, some of our bloopers, and all of our music videos. Catch up on old episodes wherever you get your podcasts. Follow us on Twitter
at walk_the_galaxy.
And ask us questions anywhere using hashtag AskWTG. Our theme music was composed by Richard Jerusik. Thanks to our listeners in South Florida and around the world. Stay safe. I'm Josh Caldwell.
I'm Hannah Sargent.
I'm Addie Dove.
And I'm Jim Cooney.
We're the AstroQuarks, signing off until the next episode of Walkabout the Galaxy.